All right. Today we're going to talk about a little bit more about center, mean versus median. So we talked median yesterday. We'll talk a little bit more about that. We'll talk about what the mean looks like and when to use each type. And we're going to introduce another measure of spread, which is called the IQR. And the IQR is going to allow us to actually quantify when something is an outlier or not. So yesterday when we talked about outliers, we said, okay, they appear to be outliers based on what we're looking at. Now we can actually put a cutoff point. Here's where it becomes an outlier versus not. And so we start with the median again. Now the median is what we call a resistant measure. This is a really key vocabulary term. And so this resistant measure means it's not influenced by outliers or skewed data. So the median doesn't care if the data has outliers. It doesn't care if it's skewed left or right. The median just cares that it's in the middle. It's right in the middle of everything that's going on around it. So because of that, anytime our data is skewed, we always want to use the median as our measure of center. We can even extend that to outliers. If I have a distribution with outliers in it, I'm going to want to use the median because otherwise my center will be influenced by those outliers. So when we use the term resistant measure, we're saying it's not influenced by outliers or skewed data. And so that's why the median is such an important concept, because we don't always have symmetric distributions. When they're skewed, when they have outliers, we have the median to kind of help keep us in the center of the data as opposed to getting pulled one direction or another. And so then the next thing we talk about is the next measure of center, the mean. So the measure of center that is called the arithmetic average. And most of you know how to calculate the mean. All you're doing is adding up all of the values in your data set and dividing by the total number of individuals. And so that's what this notation and this formula are calling for. So you add up all the x's, divide by how many individuals are in your data set, and you're calculating your average. Now, as far as the notation, this is going to be important here. Whenever we write the mean, we're going to use x bar for right now. So there's another notation we'll talk about later on down the road. Right now, we call it x bar. And so anytime you want to denote the mean, you're going to use that notation, or in a given problem, when they say x bar, you know that they're talking about calculating the mean. The mean, and this is again important here, is not resistant. And so that means that outliers and skewed data will affect the mean greatly. And so what we mean by that is if I were looking at a distribution and let's say it was skewed to the right, okay, what's going to happen is the median is going to stay as close to the center as possible. So the median is going to be pretty much right where we'd expect, where we've got 50% to the left and we've got 50% to the right. Now the mean doesn't care about being directly in the middle, or directly in the middle of all the data values. It wants to know what's the average of all the values in the particular set. And so what's going to happen is, even though we have a bunch of values right here towards the center, early on right here, these values up above are going to drag that mean. So this one, being the median, is going to be closer to that maximum, that hill that we noticed there. But the mean is going to get pulled in the direction of the tail. And so the mean would be somewhere more up here. So it's very easily influenced by high or low values that don't follow the specific trend, or if we're skewed, those high and low values within that skewed data set. So mean will get pulled in whatever direction those outliers or the tail of our skewed distribution go. And so that's why we got to be careful if we have a skewed distribution or if we have outliers. We don't want to use mean, because in that case it's going to be affected by those pieces. And so that's another thing to keep in mind when we're describing a distribution. Once we've identified the shape, we can identify which measure of center to use. If we say it's symmetric, we're always going to use mean as our measure of center. If they're skewed or we have outliers, we're always going to use median. And so that's a distinction you have to be able to make and make sure that you use as you're going through these processes. As far as calculating the mean, like we said, if I'm given a data set, so I've got my values right here, I'm going to add them all up. So I add up all the values up here. I divide by the total number of values, which was 20. And when I calculate that value, so my x bar is 31.25 minutes. The units on my mean are the same as the units for my data. Now, if we compare that mean to the median as we see below here, so they went ahead and used a stem plot to organize our values in ascending order. And so when they find the middle is in between 20 and 25. So we calculate that average. The median is only 22.5 minutes. And so this one shows you that discrepancy between the two measures. In this case, if we look at the distribution, the stem plot that they created for us, we see that it's skewed to the right. So we have this tail that's falling off to the right side of the distribution. And not only that, but we have this large possible outlier at the very top, which means my mean, as we see, got dragged towards the higher end. It got dragged over to the 31 as opposed to staying closer to the center of 22.5. And so that's the huge thing that we're talking about with this resistant versus non-resistant measure. So be aware of what your distribution looks like before choosing which measure of center you want to calculate. And so this just summarizes what I've already been talking about. If we're symmetric, we use the mean. If we're skewed or outliers, we always use the median. Okay, so make sure you keep those two things straight. So as we go to do the descriptions and things like that, you have the right measure of center with the right measure of spread, or the right shape with the right center. When we measure spread, last time we talked about range, so the maximum minus the minimum value. Now we're going to talk about a little bit different modified version, which we call the IQR, or the interquartile range. And so the interquartile range calculates what's known as the middle 50% of our data. So where do the middle 50% of all our values lie? That's what we're talking about with the IQR. So to calculate this, we need to calculate what we call our quartiles. So in our data, we have a minimum value, and this is going to be something we talk about next week. We have a quartile 1, which divides the first half in half. We have our median, which is in the middle of our data. We have Q3, which divides the top half in half. And then we have our maximum value. This is what's known as the 5-number summary, and it's something we're going to discuss in one of the topics next week. But basically what's going to happen is, like quartiles, as you would expect with the word quart, cuts our data into fourths. So instead of cutting it in half with the median, now we're going to cut it down even more with quartile 1 and quartile 3, and we get 4 pieces of our data. So that's kind of what we're dealing with there. So now, if we look at this here, it says arrange the observations in increasing order, locate the median. So that's the first thing, is we locate the midpoint of our data. Then we find the midpoint of the left side, there's our quartile 1. Find the midpoint of the right side, there's our quartile 3. And then to calculate IQR, we take the larger quartile 3 minus the smaller quartile 1. And so if we look at an example, we look back at those 20 New Yorker commute times from earlier. So they gave us the data. The first thing we do is rearrange it in ascending order. We find the midpoint of our data, which falls between 20 and 25. So we find our median is at 22.5. Then I split the data into 2 pieces. On the left side here, we find the midpoint, which is right in between 15 and 15, which means our quartile is at 15. On the other side, when we split our right side in half, it's between 40 and 45. If I average those, I get a quartile of 42.5. So then for the IQR, I take the larger quartile, 42.5, minus the smaller 15, and I get an IQR of 27.5. As far as interpreting, that means the range of the middle half of travel times for New Yorkers in the sample is 27.5 minutes. So the middle 50% of my commute times span 27.5 minutes. So that's kind of what we're talking about there. So find the midpoint, and then find the midpoint of each side. As far as identifying outliers, okay, outliers are going to lie 1.5 IQRs above quartile 3 or below quartile 1. So if I take the IQR that I calculate from my data set and I multiply it by 1.5, I'm going to add that to Q3. We call that the upper fence. So I'm going to use some abbreviations here. So upper fence is when we take Q3 and add 1.5 times the IQR. Okay, so we take Q3, we add 1.5 times the IQR. So that tells me my upper limit before a value becomes unusual, becomes an outlier. My lower fence, which I'll write in down here, so my lower fence is actually the other direction. So starting at quartile 1, I subtract 1.5 IQRs to give me my lower value. What's the lowest I can be before I become an outlier? And so these two formulas right here are ones you're going to want to know. You need to memorize them and have those ready for quizzes and tests and things like that. So if we look at the example that we just got done talking about, we said our IQR was 27.5 minutes. So if I take quartile 3 plus 1.5 times that IQR, we get an upper limit of 83.75. So anything above 83.75 is considered an outlier. And if we look at our data set, so here we have everything in order, we notice that 85 is outside of that range. So this maximum value would be considered an outlier. Okay, on the lower fence, we take our quartile 1 minus 1.5 times the IQR, and when I subtract this time, I get a negative number, which is fine. We're just looking for a lower bound. But in this case, we know that we're not going to go into the negatives. So my lowest value, 5, is still well within that lower bound. So basically what you're thinking about here is you're creating a fence on the bottom, a fence on the top. Anything outside those fences is an outlier. Anything inside the fences is perfectly fine. And so when we're identifying those outliers, it's no longer, well, it could be an outlier. It's going to be because of my cutoff points, this is an outlier, this is not, or vice versa. So with that, you should be able to work on the homework for today. And again, as always, make sure you ask questions in class or come in outside of class and get some help. Look at the answer keys to help you